Hello. Good morning. Welcome everyone. Hopefully everybody's doing all right on this wonderful Monday morning of our second week of classes. Is the audio working well? Yes, it is. Good. Mindfulness before class. Hopefully mindfulness during class as well. One should strive to be mindful at all points in the day. But, you know, that's a goal, not an automatic thing. So, yes. I can't really think of any announcements that I need to discuss with you this week. Tutorials start this week. So if you guys are, in a tutorial section, which I think pretty much all of you should have in a tutorial section, the tutorials are starting this week. So please drop by, meet your TA, see what they have to say, etc., etc. We're also going to be, the TAs didn't have office hours last week, but they will be starting to have office hours this week, so if you'd like to drop in, if you have any questions, comments, concerns, any miscellaneous belly aching that you might want to do to, the TAs are having their office hours this week, as well as for the rest of the term, as well as me. So if you need to know when that is happening, everything is in the course syllabus. Yes. If you have a question, everything is in the course syllabus. What do you talk about in tutorials? Well, I could talk about that, or I could allow the tutorials to talk for themselves. The tutorials in this class are designed as guided programming exercises. So the idea is that the TA will be doing a problem on the board. You will be following along, doing the same problem. It's sort of one of the better ways to learn how to program, in the humble opinion of your introductory programming professor, is to program along with a problem. It's like, sing along with the chipmunks. That's probably an old enough reference. Nobody's going to get it. If you are seeing a problem being done, a good thing to do is to do that problem yourself at the same time. Even if all you're doing is copying down the program that someone is writing as they're writing it, that's still a very valuable exercise. Also, I really prefer live coding demonstrations because you get to see the thought process that goes into making a program. When I do a program for you guys, sort of, I would say on the board, but it's not really on the board, is it? When I do a programming exercise, you will see me make mistakes, right? I'm not doing it from a script. I'm like, okay, so this is the problem. Plunk, 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 plunk. Does that work? Plunk, 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 plunk. It's very valuable, I feel, for you guys to see the process of somebody who knows how to program, right? Because it's like, oh, I don't know how to program. I keep making this mistake and that mistake. But if you've seen me make that same mistake 5 times in lecture, it's like, oh, well, this is just a thing that, you have to watch out for. It's not, my fault, Well, it is your fault, but, hopefully the mechanism for correcting the mistake is something that you've seen, because I've done it. But anyway, will we continue what's unfinished in Topic 1 today? Yes, and in general, that is what we're going to do for the entire course, is we're going to be always slightly behind on the lecture material, and we're always going to be catching up, because that's just the way it works. But don't worry, we will have finished most of the lecture material by the end of the class. We might have to go through some of the machine learning stuff a little quickly. We usually do, but that's okay because it's not the essential stuff. It's better to spend more time on the essential stuff, I think. The tutorials are on MS Teams. Nope, the tutorials are on YouTube. If you check the course syllabus, you will see there's a great big table. Actually, I suppose I could just show you the table rather than alluding to it mysteriously. It's in the course content. If you go to Overview, you'll see the course syllabus laid out before you. If you take a look, here are your tutorial sections, your corresponding tutorial TAs, and links to their YouTube channels. So you can click those. Those are links. There you go. I believe I have all of the TA's YouTube channels are also linked to on my YouTube channel, so you can also access them that way if you wish. So there you go. Cool. Yeah, so let's get to it. Right. So we were just about to get into this, the third real topic of this lecture slide. We were going to talk about flowcharts. So flowcharts are a tool for helping you to visualize the way that a program can be constructed. I would say that it's not even like it's kind of an entry-level abstraction. So when you're first learning how to program, it can be useful for you to sort of think in flowcharts. Most of you should have a reasonable handle on the idea of a flowchart already. They're, even if you don't, they're reasonably intuitive. So the idea is, you can think about a program as being similar to a flowchart. Generally speaking, once you have acquired some degree of facility with programming, you will no longer need to think of them as flowcharts. You'll just be able to do them as code, natively in your brain. But the flowchart analogy can be very useful if you're trying to learn what a construct does, for instance. It also relates to this idea of control flow. So the idea of control flow is extremely, extremely important inside of the context of programming. If you want to get down to and so I realize we're starting in real heavy today, but this is it is extremely important for the entire rest of the course that you guys pay attention to the next 20 minutes, because the next 20 minutes will make or break your success in this course in a very real sense. So everybody get your pens ready. So what is a program composed of in real terms, right? You've got instructions, and you've got ways to manage which instructions are executed when. So, we've talked about how programming in Python is programming in an imperative language. It thinks it's object-oriented, but that's sort of beside the point. Fundamentally, a Python program is organized as a series of instructions. Those instructions are executed by the CPU, and every instruction modifies data within the computer. That is programming. You are performing operations on ones and zeros. That is all of programming right there. So you have the instruction. The instruction is kind of the base unit of the program. It's like instructions are to programs as molecules are to, a living organism. Notice I didn't say atoms because, as we're going to see, instructions are composed of other parts that are also important. But I think the correct level of analogy is an instruction as a molecule. So when we are talking about flowcharts, if you have a box, a rectangle, with, some operation inside of it, that is an instruction in the sense of a flowchart. You can have multiple instructions that are sort of, in one box. There will be an implicit order in which these instructions are executed. But, we call these statements. That's a very important term. So a statement, actually, technically a statement is a more general term. Anyway, we'll get into it. Instructions. These are very important. So instructions can be a lot of things. They generally it's like statement, command, action. We'll see what instructions can be. How long does it take to produce the output for a particular input? To turn a green light on, to continue straight ahead, or subtract v from u? It really depends on the operation, doesn't it? Generally speaking, though, the instruction does not take very long. What takes long is loops. Generally speaking, if you have long run times, it's because of looping. How many resources, like memory, are needed in the process to process a particular instruction? Again, it really depends on the instruction. So this guy down here, this branch, this is a very important idea in programming as well. This is the idea of a condition. So if you have done even a little bit of programming before, you'll probably have brushed up against the idea of an if statement. So if statements are they're the water that the fish swims in. If you're a programmer, if statements are they should be so second nature to you that you can do them without even really thinking about them. What an if statement does is it allows you to select between groups of statements based on the internal state of the program. So in in an if statement, you have some sort of conditional expression. You have some sort of condition, right? In this case, it's called B. The reason it's called B is because these are expressions in Boolean logic. Boolean logic is a specific type of logic. It's a specific type of expression. You can think of it as like a secondary type of arithmetic that operates only on true and false values. So you have a condition. If the condition turns out true, then you execute one branch of the program. If the condition turns out false, you execute another branch of the program. By having if statements, you can have the program modify its behavior based on its own internal condition, which, as it turns out, is extremely essential if you're doing anything other than, simply reproducing the functionality of a mathematical formula. Anything that involves any kind of sort of intelligence by the machine is going to involve if statements. So, let me just see let's see if we have any. If it statement is kind of like the x-intersect example we did last Thursday. Yes, an if statement would certainly be required in that case. Most particularly, at a certain point you have to move the bounds in based on whether the midpoint is above or below the x-axis, right? So whether the midpoint is above or below the x-axis, that is the condition, and moving either one bound in or the other bound in, those are the two branches, right? Yeah, so exactly. Can you go to any tutorial that works out with your schedule? Yeah, I don't have a huge problem with that, as long as we don't have 200 people all ending up in one tutorial. That would be a bit much. But generally speaking, things are pretty, we don't really we don't have to worry about the rooms filling up anymore. So, yeah. I don't mind if you guys, move between tutorials. But generally speaking, you should try to stick to the one you have if you can, So, hierarchically structured flowcharts are composed of basic instructions, sequences of instructions, and then, optionally, there are start and end points. The start and end points are circles with arrows coming out of and into them. You can, this is kind of just explaining what a flowchart is, so I won't dwell on it too much. But, there is an ordering that's implicit in this flowchart idea. So, this is a lot more important, because this actually translates directly into programming code, as we'll demonstrate. So we've got two different types of selections. We've got the if B then S construction. So we have this condition, B. If it is true, if we have yes, we go into statement S and then we continue. If not, we rejoin program flow after the statement S and then we just continue on. So this is another way of saying this is if B, then S. Otherwise, do nothing. Otherwise, do nothing is important, because it's not the only way of constructing it. We also have, if you want to put a statement on the no branch, then it becomes if B, then S, else T. Else T. Very important. So if we have the condition is true, we do S. If the condition is false, we do T. This is, again, a very common way of constructing a language. And then we have repetition. While B, do S. So we have a condition. If the condition turns out true, then we execute statement S. And once S is completed, we go back up and reevaluate the condition. So long as the condition is true, we are stuck inside of a loop. And this is why it's called a loop, is because it goes around and around and around and around and around. You only exit the loop if the condition comes out false, and then you continue on with your program. So let's see what this actually looks like in terms of some programs, shall we? cd documents McMaster 1MD3. Yeah. This is Linux. For all of you people who don't know, who've never seen Linux, this is what Linux looks like. Make directory, code, go into code, and get it, let's call it topic1.py. So, generally speaking, when you create a Python source code file, the file extension on that is .py. Ooh, got lots of questions. So instructions are linear with only one outcome. Yes, that's actually a very, very important, that's a very important distinction. Yes, so instructions will have, they will only do one thing, right? Even an if, like if you consider like an if statement and all of the statements that are contained within it, if you consider that to be one software entity, it has one entry point and one exit point, as we'll see. Will there be any videos on how to set the software up? Yeah, I think Marco's going to be doing one of those. That's kind of the point of the tutorial. You don't have to have Linux to be able to do this, but I have Linux, and so I'm going to use it. So, let's write a Python program. So, actually, maybe I want to do this in the interpreter. Yeah, I want to do this in the interpreter. So, in Python, there are a couple of ways of going about writing a program. One is to write a file, and then execute that file, which, you know, it executes all of the code inside of the file all at the same time. You can also, in Python, execute one statement at a time, one piece of code at a time, by opening up the Python interpreter. So if you get these three greater than signs, this is the Python interpreter. You can enter code into this, and it will calculate things for you. So, for example, if I say 4 plus 3, that's 7. If I say 4 to the power of 3, that's 64, etc., etc. So, if we have an if statement, we can say if 4 is greater than 3, print hello, else print goodbye. And you can see it prints hello. It prints hello because 4 is greater than 3, right? So, and we're going to get into, like, don't worry if this is, if this seems arcane, we're going to be getting into how to do all of this very specifically. And we'll do all of the different symbols you can use here and what they mean, etc., etc. This is really just to introduce you to the idea. If, on the other hand, you had 4 is less than 3, and you, you know, entered all of the same things in again, then you would get the other branch executing. This is your best friend right here. This is a print statement. The print statement just makes you know, a particular word or phrase, something delimited with quotation marks. It makes it appear on the screen. Again, we're going to get into different types of data types that you can have, but strings are pretty important. Anything that's between quotation marks is called a string, which basically is telling the computer, these are characters, and you should treat this as a collection of characters rather than as a numerical value. Yeah. So there you go. If statements. While loops are a bit different. That one I am going to do here. So let's say we had I is equal to 0, while I is less than 10, print I plus equals 1, or I is equal to I plus 1. Very simple loop. There we go. Execute code topic 1.py. There you can see that this piece of code executes 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because it starts at 0. So the way that the program flows is the first thing that happens is a variable I is created and assigned the value 0. This is called an assignment statement. Assignment statements are your bread and butter, even more fundamental than conditionals. While I is less than 10, I being less than 10, that is the condition, right? The condition for the loop. So long as this is true, the loop will be continuously executed. It will be looped. When this condition is no longer true, you will break out of the loop. You'll no longer be stuck inside of it. So this loop does two things. Number one, it prints the current value of I. And number two, it performs what we programmers call an increment operation. So I is assigned 1 more than its current value. So obviously, if its current value is 5, then it becomes 6. If it's 6, it becomes 7, etc., etc. So once I is 10, 10 is not less than 10, right? So that means that this statement, which would print 10, if the loop were continuing, doesn't actually occur, so we don't actually see that as output. So that's loops in very basic terms. Boink. Is there a Python equivalent for plus plus? So that's a good programmer question. No, there's no plus plus in Python. Python's an interesting language. I'm talking to people who know who know other programming languages right now. Plus plus is not like one of the design philosophies of Python as a language was to try to minimize redundancy in the language, quote unquote. So according to the Python people, the people who designed the language, because plus you can express the same thing that plus plus, which is the increment operator, because you can express the same thing with plus equals 1, having both plus equals and plus plus in the same language is redundant, so they removed plus plus. You'll also find if you know switch statements that Python doesn't have switch cases, which is a very weird omission. At least I would consider it a weird omission, because pretty much every imperative language that you'll ever see has a switch statement, switch cases, but Python doesn't. Yeah. So when would you use while loops versus for loops? In Python, you use while loops whenever you have to do something numerical on indexes, and you don't want to use a for loop. And for loops are, generally speaking, most effectively applied to data structures. If we set I equals 0, would it not always be less than 10? Well, that's the thing, right? In this program, the value of I is being modified as the loop is executing. So eventually, because, it doesn't really matter what number you start out with, as long as it's less than 10 to begin with, if you keep incrementing it by 1, you'll eventually hit 10, right? Even if it was negative 11 billion, it would take 11 billion and 10 executions to get to 10, but you'd still get there. But yeah, that's a very, very important distinction. I is not a constant. This is not like pi in math. I is so this is a very, 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 very fundamental distinction between algebraic variables and programming variables. It's very important to understand this. In programming, a variable is a container for data. The best way to think of it is as a container for data. You can put data into the container. You can get data out of the container. The data in the container can be modified at any point in the program. It's not a constant unless you explicitly declare it to be a constant via, various mechanisms, which, we'll see perhaps a little later on. It's possible to make a variable into a constant, but you have to do it explicitly. The sort of default orientation for a programming variable is it's a box that you put a number in, and if you put another number into it, it overwrites the previous number. So, you know how when you're modifying a file on a computer, if you modify the file and then save it, that overwrites the previous state of the file, right? That previous state of the file no longer exists. Variables are the same way, but on a micro scale. If you write to a variable, the new value completely replaces the old value, and it's impossible to recover the old value. You would have to have saved it to a different variable before you overwrote it. But yeah, very important. These are not algebraic variables that we're dealing with. These are segments of memory. The correct way to think of a variable is as a piece of the computer's memory that you have direct control over. So yeah. What would happen if I did not limit it? That's also a good question. So if, for example, this while loop, if I one way of making this an infinite loop is you could just write true here. So these true and false are the Boolean literals, and you can use them like numbers in programming. But if you had a while true, if you had a condition that never became false, and this is a real problem, the computer will execute the program literally forever. It will never stop. Actually. If I were to compile and execute this code right here, in terminal, I would have to catch it before it went too far, because actually executing this could just crash my computer. Actually, this could crash my computer right here. You have to be careful when you're programming. It depends on the language. Some languages have better protections than others against this sort of thing. Certainly if you were running a C program, basically the lower down, the closer to the actual hardware you are, the more damage you can do. But, and generally speaking, the consequences of an infinite loop is that, in Windows where it's this program is unresponsive, and sometimes it's just because it's taking a long time to load, but sometimes it's because the program has actually, ceased to operate and it's just frozen. Infinite loops cause programs to freeze because the program is stuck inside of this loop. This loop is the only thing that the program can do because it can't escape the loop. Because it's stuck in a loop, it can't take any user input anymore. So it'll just run forever. It will run forever. It will run until the computer eventually breaks and, civilization ceases to be and Judgment Day comes and all of us are, perish in the inevitable cataclysmic falling of the earth into the sun. But yes. Can you see for science? No, I'm streaming right now, so I'm not going to put my computer intentionally into an infinite loop state. But you're welcome to try that out on the Jupyter server. But you'll have to. There are instructions in the assignments on what to do if you get yourself into an infinite loop. But there's a stop button at the top that you can interrupt program execution with. Nope. It's only science if you don't know what the outcome is going to be, and I know what the outcome is going to be, so. Yeah. Is there a difference between an integer and a double? Well, first of all, we call it declaring a variable, not claiming a variable. Declaring or instantiating, not claiming. But, yes. Although it's yes and no. In Python is a dynamically typed programming language, so it's kind of Python's kind of the the hippie of the programming languages, because it's like, hey man, you can be an integer, you can be a double, you can be a float, I don't care, you could be whatever you want to be, man. That's what Python says to you for variables. But so a more technical description. In Python, a variable, you may have noticed, those of you who are more used to something like Java or C++ or something, the variable I has not been declared with a type. In Python, things have types because you use them in specific ways, not because you declare them with types. So if later on I were to assign a floating point value to the variable I, then I would become a floating point number rather than an integer. Python has decided that that's something that it's going to handle in the background and not have you worry about. And that's, you know, it's a dynamically typed programming language. But yeah. Yeah, so it's a little bit like var, yeah. Except I'm pretty sure var, there are still distinctions. Like if you declare a variable with var, I actually don't know, but it might be that they imply, like they calculate what the data type is supposed to be from the thing you instantiate the variable with. And if you violate that type later on, then it'll still be angry with you. That might not be the case. You know, Mark probably knows. So no, you don't have to cast anything in Python. You can, for those of you who are used to things being cast, everything is cast implicitly when you assign a particular data type. Yeah. C vars are still statically typed. Thank you. Yeah, okay. Cool. So yeah, everything's loose. Everything's loosey-goosey in Python. Probably everybody who has not programmed before is completely lost by all of that. But yeah. So yeah, that's you know, this is good for people who already know some programming. Like Python is like a very interesting animal. Like there are also no like explicitly defined return value types from functions, so you can literally return any type from a function. Like anyway, so let's talk about some basic instructions. I've already talked about some of this. The basic instructions of flowcharts are those which the underlying machine has for changing state. So we have what is called the assignment statement. This is read x becomes e. This is the math speak, the math notation for an assignment statement. Inside of the Python interpreter, x is equal to 9. If we ask for the value of x, it is 9. Assignment. The sort of real concrete value of 9 is being stored inside of the container we are calling x. Yeah. In Python, you can do multiple assignment statements at one time. You can say x comma y is equal to 1 comma 3, and then x is 1 and y is 3. You know, you can do things in multiple things per line, but I'm not sure why you would want to. All that that's good for is making your programming code shorter without making it more efficient, and therefore making it more difficult to read, in the humble opinion of this professor. You can also perform basic arithmetic. So, for example, if we wanted to assign a variable z to y minus x, z is 2. There you go. You can perform arithmetic on variables and store the results of that arithmetic in other variables. So this is actually kind of interesting. Anywhere that you have an expression, you can actually substitute in a, you know, anywhere that you have a variable name in a statement like this, you can actually substitute another expression, and it works out just fine. So, yeah. So, yeah, arithmetic. You can do arithmetic. Oh, big flowchart. Okay. You would have to load Euler's number. So, yeah. You would have to, like, import math. I think this is how you do it. Import math pi. Yeah, there you go. So sometimes if you're trying to find something like e or pi, that will be stored inside of a particular library. The import statement loads a library in. So what that does is, there's a set of values and functions and classes that are stored separately that are not loaded in by default because you don't always need them, and it's better to save on the memory, generally speaking. And if you import them, then you have access to all of these things, like the value of pi. So you don't have to write in 3.14 every time you need pi. I pretend to know, but I just pulled up Stack Overflow. That is programming in a nutshell. So there you go. So this is a program. This is a program for taking three numbers and calculating which of those numbers is the median. So let's actually do this in programming. Boop. Ba-boop. There we go. So I'm going to define this as a function, median, just because it's a good idea to define things as functions. So x, y, and z. A function taking x, y, and z. If x is less than y, that's this guy right here, we do some stuff. Otherwise, we do some other stuff. We can fill in the other stuff at a later point in time. If we go down the yes branch, we end up with this guy. If z is less than x, do something else, do something else. If it's true, then we set m is equal to x. So m is equal to x. Otherwise, we have one more if statement. If z is less than y, we set m is equal to y. So I want to just say one thing, particularly for the benefit of people who have programmed in other programming languages, but also for the benefit of everyone. What is or is not inside of an if statement is defined by indentation in Python. So in other programming languages, what's inside of a function or an if statement is defined by, like, curly braces, right? If it's inside of two curly braces, then that's inside of a thing. But if it's inside, like in Python, we define that by indentation, rather. So everything at one level of indentation further than this declaration of the function is inside of the function. Everything that's indented one level further than this if statement is inside of this if statement, right? So, we'll get used to it. But basically, you have to put the semantics for what's inside and what's outside of a programming construct somewhere, and Python decided to load that on whitespace. So it decided to make the number, like the tab level, the indentation level, important. It affects how the program is executed. So you have to, in other programming languages, this was done, but it's more conventional. It doesn't necessarily have to be done, but, it's the general form that people follow when they program, so, everything's fine. In Python, they decided, what, all of these curly braces, these are all redundant if everybody's using indentation to indicate everything anyways, so let's just make the indentation itself the thing that indicates whether or not something's inside of an if block. So that's the way that they did it. So on the other branch, we get x is less than z. And if true, we set m is equal to x. Otherwise, we have one more if statement. Z is less than y. Y There we go. Thank you. If true, m is equal to y, else m is equal to z. And then at the end, we want to return m. So what the return statement does is it's like, okay, this is what I want to produce as output from this function. So if it's not good enough to simply define the function, we also need to actually execute it over some data. So, for example, if we ask, what is the median of 4, 8, and 10? Whoop, I should use commas there. There we go. Actually, you know what? Let's put them in not the order that would... All right, there we go. And we execute. Oh, we actually have to print that as well. Otherwise, it won't actually show on the screen. There we go. So the median is calculated to be 12? Question mark? Did I do that correctly? That doesn't seem correct. All right, so 12. Because the median should be 10, right? Maybe I made a mistake. So why? This is called tracing, by the way. So 12. So we would have 4 is less than 12. Yes, that's true. 10 is less than x. That's not true. So that goes here. If z is less than y, so if this guy is less than this guy, then haha, I did make a mistake. That should be z, else m equals y. There we go. I made a mistake, and I fixed it on stream for your benefit. This is how programming works. And there you can see, now we get the correct result! That's the thing about programming, folks. The computer is not going to read your mind. It is unreasonable to expect other human beings to read your mind, let alone a machine. When you write a program, you must write the program sufficiently explicitly so that, you know, the computer doesn't have you, like, if you're expecting the computer to do something that you haven't actually written down, then you don't know what programming is. But yeah, there you go. Yes, thank you. I figured that out. Yes, I did. How do you determine the level of indentation you need in the code? It really depends on the code that you're writing. So every time you... So it's like... We think of programming as being... we think of groups of statements as being like code blocks or statement blocks. So everything inside of a function, like you want to have one block of code inside of a function. That's what a function is. It's a set. It's an amount of code. It's like, okay, I'm going to refer to this code by this name so that I can refer to it later. So this is a code block. It's all one code block because you can see it is at least indented by one space. The else, the if, and the return statement, those are all at sort of the function block level, right? All of this stuff, this is all indented by at least 2. So all of this is inside of this first branch of the if statement, right? In the slides, this corresponds to this area of the code here, right? This area of the code is all inside of this branch, so that's further indented one level. This, you know, this statement right here is inside of this branch, inside of this branch, inside of this branch. So it's like, you can also kind of do it like, you know, this is a function, so indent 1 level, 2 level, 3 level, 4 level. 1 level, 2 level, 3 level, 4 level. There is a correspondence, right? So yeah. Why leave space before the colon? That's actually just for, like, so that is just the way I program. Technically speaking, it doesn't matter whether you have a space here or you don't. I think it's a little cleaner if you leave a space there. You'll also, like, I think technically speaking, you don't have to have these braces either. But I do it just because, yeah. So there are some things that you're going to see me do which are kind of just stylistic choices. You know, like I've been programming a long time. I have a particular way that I like going about it. I like to see my code look a certain way, so I use a certain amount of redundant characters to code because I think it looks nicer, basically. It's kind of like it's kind of equivalent to the idea of, do you leave two spaces or one space after a period when you're writing a paragraph? It's like on that level of like stylistic choice. So yeah. So why do this median? So having defined the function is different from having executed it. I have defined the function, but I have not executed it over any code, right? So if I were to leave this statement out, by commenting it out, you can toggle whether or not statements exist in the program by using the hashtag, also known as the octothorpe character, to toggle whether whether lines of code exist. If you do that and run it, it just does nothing. It defines the function, but it never runs it. In order to actually run the code, you have to invoke the function. So this is like, it's not sufficient to merely say what the code does. You have to actually give it some input to expect some output. That is programming fundamentals. No input, no output. So there you go. Yes. So in mathematical terms, it's colon equals. In Python, it's just equals. How do I add comments in Python? There's no block comment in Python. I mean, sometimes people consider triple quotations to be block comments, but it's technically a doc string, although I think you can also use it that way. Comments in Python are octothorpe characters. So a comment in a code, we're going to get to this, but if you can write like random stuff, hello, boys, that's, that's not going to be executed as code. That's just a comment. A comment is a way of leaving yourself notes within your code to be able to tell what the heck you were doing. Comments are extremely helpful and useful. I highly recommend the use of comments. It's like, this is a median function. It's like calculates the median of 3 numbers. A textual description of what the function actually does. Because, you could figure out what this function is doing by reading the code and sort of reverse engineering it in your brain, or you could just leave like 6 words in regular English above the function that describes what it does, and that's much more easy, to read later. Yeah. Yes, that's a good analogy. Defining a function is like creating a tool, and executing it is the actual use. Absolutely. We have defined a wrench, and this is where we use the wrench. Absolutely. And that's the correct way to think about programs as well. Programming is a tool that operates on numbers. Yes. So, I know we didn't get too far into the slides, but I feel like that was a really important lesson anyway. It is now 10:20. I will remain behind to answer any questions that you may have for a few minutes. But otherwise, thank you very much for listening to me rambling on about programming today. Yeah. Cool. Let's see if we have any questions. Poggers indeed. Will a practice assignment be loaded this week? Yes. Once we get everything sorted out. How do you get participation marks? In another class. We do not do participation marks in this class. You will not get any, so there's no point in worrying about it. How do you open Python on... Well, I mean, I think on Mac it's just Python, not Python 3. I think Python 3 is the specific Linux way of going about it. But, yeah. When will the JHub server be online? Hopefully within the next couple of days. How do you run a program from the command line? Just this way. You type Python, or in Windows I think it's Python. In Mac it might be Python, I'm not sure. But in Linux it's Python 3. And then you specify the file name and press enter, and it executes it. Could I explain the indentations again? Yeah, so everything inside of here, everything that's indented at least one level is inside of the function that we're defining here, the median function. Everything that's indented at least 2 levels is inside of this if statement. Everything that's indented in 3 levels, at least 3 levels, is inside of either this if statement or this else block, right? So the level of indentation tells you what is inside of what, which is good. You'll get onto it. Try a couple of problems on coding bat and you'll start to get the idea. Yeah. Yes, it's entirely probable that you have invalid syntax. Invalid syntax means you have that means you have an improperly formed program. So, like, if I misspelled print, for example, you notice it automatically unhighlights it. But if I misspelled print and then I tried to execute it, it would say, yeah, name print isn't defined. But that's a type of syntax error. So, print. There we go. Okay. Can you explain the purpose of return m and why you need it? Yes, so if you leave it out, then the function doesn't return anything. So when we're doing this, what's happening is the function is being executed like it was like addition or something. If I put like 5 plus 3, it calculates the value of 8 and then puts that into these braces. What happens when you call a function is it runs through all of this code, and then whatever is returned by this code, it puts it here and then continues on with the program. If you don't actually return anything, then it just does the Python default value, which is none. So there you go. Does having a no option for a conditional statement allow you to have X, Y, and Z in non-numerical order? Yes. So I guess. So by no, you mean, I think, the else statements. And, well, that's kind of the whole point of the branching structure anyway, is, like, we're not assuming that X, Y, and Z are in any particular order, right? Otherwise, like, if we could assume that, X was less than Y and Y was less than Z, we wouldn't need any of this. All we would need would be the statement return Y, because Y would already be the middle. It would already be the median just by construction. So the whole point of the if statements is because we are not assuming X, Y, and Z are in numerical order. There you go. Why use Python from the terminal instead of using something like PyCharm? Because you're teaching a class. I'm using the terminal because I'm in Linux, and this is just like a really simple way of doing it. You know, you can use whatever environment you want to do Python. I find it instructive to demonstrate that you actually don't need any fancy IDEs to do Python. You can do Python with just a command line and a text editor if you want to. In fact, I often do programming that way. But, yep. How does it return M if you didn't assign it to anything? Well, I did. I assigned M here, and here, and here, and here. Those are all assigning something to M. And if you actually look at this, there's no branch in this program that doesn't assign M to something. However, if you're the type of person who's paranoid about it, you can say M is equal to -1 up at the front, and then if you have -1 here, you'll know that, you know, something went wrong and M was not assigned at any point in the program. So there you go. Oh, maybe that's not what your question is. How does it return M if you didn't assign anything to it? I think if, like, for example, if you return something that we didn't use, like, you know, P, like a variable that's undeclared, I think it'll just say P is not defined. That's a syntax error. Returning something that hasn't been defined yet is a syntax error. The same way that using something that hasn't been defined yet is a syntax error. However, Python's a little strange. Python is an interpreted language, which means that it will only find a syntax error if it tries to execute it. So you can have lots of syntax errors hiding in your code in branches that have never been executed. But yeah, there you go. Ta-da! Okay, I think if there are no more questions, I'm going to log off now. Yeah. There we go. Okay, cool. Take her easy, folks. Good luck on the rest of your classes today. See you tomorrow. Ba-boom.